Hello everyone and welcome back to C# Advanced Tutorials. My name is Steve Bishop, and in this video we're going to take a look at delegates, lambdas, action of t, and func of t. Now in our previous video we talked about how to reverse the dependencies of our application using delegates and events. Now some of the code looks pretty messy after we did this process. Yes, we've definitely reversed the flow, and this is really useful in some ways, but there's probably some syntactic sugar that might be able to make this a little bit easier to understand. And that's where lambdas, action of t, and func of t can really help clean things up. Now we can write code that looks something like this. We can still have the same reversal flow, but now we're using action string postback for our log service. And when we do our postback and what we're assigning our function to be when that postback event is raised, we can actually just do a lambda expression in our main method. The process of understanding how this happens is something I'd like to cover in this video. So without further ado, let's take a look at some code. Now, like in our last example, I'd like to just go ahead and use Visual Studio Code, and I've got a special theme going on here. So don't worry about the color scheme. It's still Visual Studio Code. What I'm going to go ahead and do, though, is create a brand new .NET application. I'm just going to change directories to my projects folder. And I'm going to go ahead and make a .NET new console. And I'm going to say that the output is going to be C#_lambdas. Now that'll actually create a subfolder for me and also create the project folder or project file inside of that folder. Now we can go ahead and change directories into that C#_lambdas. And if we look inside here, we can see there's my CS proj file and my program CS file. So let's go ahead and open that folder up now. C#lambdas. And I'll close the welcome screen and click on the program CS file. And just like last time, we had a little window that pops up here saying it needed to build some stuff. So we'll go ahead and click yes. And I'm going to go ahead and get rid of my console.writeline.hello world there, because obviously we don't need that. So in a very similar way to the way that I did the delegate explanation in the last video, I'm going to make a similar class here called MathService. And to start off with, I'm going to go ahead and build a public event called event handler, or of type event handler, of course, which is the more common or default event handler that that .NET provides for us. Now, I'm going to pass into this event handler a data type, a type parameter of math performed event args. And I have not yet created that class, so we'll need to do that in a moment. But I'm going to call this event math performed. And let's go ahead and bring in that event handler using system. And for math performed event args, I need to go ahead and create this class. So I'm just going to use my IDE to help me out with that. And it looks like I just realized I did a colon instead of semicolon. All right, there we go. And let's go to our math performed event args, and we're going to say it's going to inherit from event args. So we need to go ahead and be using system again for that. And what I'd like to go ahead and do with this particular math performed event args is I'm going to add the property of type double as the return type. I should say of the property type, and the name is going to be just simply result. Okay. Going back to our math service, let's go ahead and add a function on here that's going to be returning void, but we'll call this multiply numbers. And just like in our last demonstration, we're going to do double value 1, double value 2. And to simulate that this is a service, I'm going to go ahead and add a timer that's going to cause a delay in how long it takes for this to actually work. I need to bring in the namespace for that. So we'll do, it's actually under using system timers. And then I'm going to go ahead and call that math performed event. So I'm going to raise that event, I should say. And remember, since we're using the event handler, which is a default delegate type, I need to go ahead and pass in a sender, which is going to be this, right? And this refers to my math service, the entire class. And then I'm going to go ahead and create a new math performed event args. And I'm just going to go ahead and say that the result is equal to value 1 times value 2. So we're just kind of taking some shortcuts to what we did the last time. And now we need to go ahead and consume this. So we're going to go ahead and go back to our program class. And let's actually use this new math service. So we're going to do math service. I'll just call this math serve and set it to a new instance of the math service. And now we need to wire up to that math performed event, right? So we're going to do math serve. We're going to do dot, and there's our math performed event. So when it is raised, we're going to subscribe to it. And this time, what I'm going to do is, you may recall last time, I just did some sort of function, right? So I would say something like a static void, and we want to call this on math performed. It would receive the sender, which was an object. And then we would say something like the math performed event args, and I'd called it args, or more commonly you'd see this as E. And then we could just simply say console.writeLine, and we'd just say something like calculation result was E.result. Okay? And then we just needed to wire that function up. So our onMathPerformed function is what we actually want to call when the mathPerformed event is raised. Now we need to actually do something with that service so that it actually triggers, and that's that multiply numbers function. And we're just going to pass in some values here. We'll just come up with some random numbers here. 0.85 and 783 .726. Okay. And of course, if we run this, assuming I didn't fat finger anything, if I do .NET run, this should go ahead and print out the results of multiplying those two values together. Perfect. Okay, great. Now, this is a little bit messy in that we've got our function kind of declared as a separate function altogether. You don't actually need to do this. One of the things that you can do is create an anonymous delegate, or sometimes called an anonymous function. And the way you do that is, let's say that this, instead of onMathPerformed, let's actually call this, let's give this, instead of assigning it the onMathPerformed function, we're going to actually assign to it a delegate. And the delegate is actually capable of receiving object sender math performed event args E. And then after this, we can actually just go ahead and do open and close curly braces, defining the code that we want to run. So I'm just going to take this console.writeLine and move this up here into our delegate. And then I don't even need the onMathPerformed. I can just use a delegate as an anonymous function right here in our code. And when I do that, you'll notice, ta-da, the same exact code runs just fine. So we've been able to assign this anonymous delegate or anonymous function to the math performed, but there's actually a very easy syntax that we can use. We can shrink this delegate down to something called a lambda expression. And it's basically just a way to rewrite a delegate. It's a little syntactic sugar that's been introduced into the C# compiler. So what I'm going to do is, to write a lambda expression, I'm just going to remove the word delegate here in front. And I can also remove the data types for the parameters. So we're going to remove those data types from the parameters. And now between our parameters and our open and closed curly braces, I'm just going to put what's commonly referred to as the fat arrow, or lambda. So we now have described here the two parameters that we take for our function, and then the code that we wish to perform when that function is raised, or when that function is called. So we're going to go and do .NET Run. And once again, the same thing. We get our 45,340.516. Now, personally, I think this is a little bit messy to be using the default event handler because we have to use the sender and E, and, all we really want to do is just take the result and print it out to the console window. So doing these default with event args and everything is a little bit extra in my opinion. So what we're going to do is in our math service, I'm going to go ahead and comment out this event handler, our math performed, and I'm going to create my own delegate. So we'll do public delegate. I'm going to make this a void delegate as the return type, and it's going to be called math performed. And since this is a delegate, I like to say handler. And it's going to receive double result. So it's going to just be that result. Now, instead of doing this whole math performed function call like that, or I should say event raising that we were doing before, now I just need to have some sort of property on my math service of type math performed handler that I can raise and just pass the result alone to. So I'm going to go ahead and create a new public event of type math performed handler, and I'm just going to call this math performed, just like it was before. Now, when I do my math performed raising, I'm going to raise this differently defined event. It's not using the event handler delegate, and we can just go ahead and pass along value 1 times value 2. So now all we've really done is just defined our own custom delegate instead of using the event handler delegate. And we've added our own special property here for our event called math performed that uses that newly defined delegate. If we go back to our program, we're going to see this kind of causes some problems, but they're really not that big. All I really need to do is just change that since this delegate is only going to be passing along one single parameter of result, I just need to change this from 2 parameters to 1 parameter. And of course, since my E is no longer a parameter name, I'm just going to say result. And now let's go ahead and rerun our application. And there we go. Now we can use our own custom delegate back in our math service to do a very simple Lambda expression wherever we want to. Now, I'd like to take this one step further. So we learned that we can go to a math service class on our math service. We can create this public event of type math performed handler and create a property on here, right? So it's basically an event, but it's like a property on the class. Well, if this math performed handler is a data type, is it possible for us to have a data type that could be passed along as a parameter? And the answer is absolutely. So what I'm going to go ahead and do is I'm going to create another delegate here. I'm going to say public delegate. I'm going to go ahead and have this delegate return a double, because what I want this to do is, let's say that my delegate that I'm going to define here is this actual calculation that we're doing right here of value 1 times value 2. But what we're going to do is we're going to make it so that multiply numbers, since it's no longer going to contain that actual calculation, we're going to allow whoever's calling multiply numbers to say or define what the calculation is that we want to perform. And since value 1 times value 2 is really a calculation that's going to return a double, then I need to define on my delegate that it's going to return a double. And I'm going to go ahead and call this calculation handler. And it takes in a double of value 1 and double value 2. Now I can say that a third parameter for my multiply numbers is of a type calculation handler. And I'll just call this calc or calculation. So now what I'm going to do is, since this calculation handler delegate is actually going to then be assigned a function that will receive value 1, value 2, and return a double, I can replace the actual calculation that I'm doing here that I'm just hard-coded into the multiply numbers function and actually say, no, what you're actually going to do is call the calculation delegate, whatever the function is that's assigned to that delegate, and pass along value 1 and value 2 to whatever that function is that's defined for the calculation handler. Now we're still going to go ahead and raise math performed. So we've got kind of like this double delegate thing going on here, but really there's no actual processing or calculations being done within the MathService, which is pretty cool. Now, since this is no longer, the name multiply numbers is no longer properly reflecting what the process is that this function is doing, I'm going to change this name to calculate numbers. And I don't know what that calculation is. I'm going to leave it up to whatever that third parameter is that gets passed in for the calculation to actually figure out what that actual calculation is. I'm just going to pass along value 1 and value 2 to the function that is being assigned to calculation. Now, if your head hurts, don't worry. Mine did the first time I saw this. But if you just remember that these delegates are something that could be assigned to later. So the actual implementation details for what calculation is something that calculate numbers doesn't actually know. All it knows is that it can call that calculation function, whatever it is, and pass along value 1 and value 2 to it. And the result that it will have back, because it is a data type of calculation handler, it knows that it will return a type double. And since it will return a type double, it can pass that return type double to the math performed event. And the math performed event is a delegate of type, math performed handler, which receives a result as a type double. So we can raise math performed, which is of a type math performed handler, receives a double as a parameter, which will be the result of this calculation function, because the calculation function will return a double after it is done. That's a lot to go through. You might want to take a few moments to process exactly what we've done here and maybe go back through and look at the code. So now that I've changed how my MathService operates, I need to go back to where it's being consumed and fix up some of the syntax here. I'm going to go ahead and leave my math performed assignment to this Lambda expression, but now I just need to change how this multiply numbers. It's no longer just multiply numbers, it's actually calculate numbers. But there's one other thing that's happening here is it needs that third parameter, right? Calculate numbers on our MathService takes in this calculation handler. And we learned earlier when we were going through and assigning to this math performed, this math performed event, which was really just a particular delegate that receives one parameter of type double. Well, if we have on our math performed as a math performed handler of that delegate type, and this is a delegate type, and we assigned again to that delegate a Lambda expression, does that mean I can just pass along as my third parameter a Lambda expression? Absolutely you can, as long as that Lambda expression matches the delegate, right? Where we take in two doubles and return a double. So let's go ahead and create a Lambda expression that takes in two doubles, or two doubles for parameters and returns a double. So we're just going to say value 1, value 2. We often say goes to, and then we say value 1. This is going to be the actual calculation we want to perform, right? This is the function times value 2. I could wrap this up in curly braces so that this is a little bit more to your typical understanding. We're going to return value 1 and value 2 in curly braces with a semicolon there. Just fix the formatting a little bit. And so we just basically defined a function as that third parameter that we're passing to the calculate numbers function. Now, I could shorten this up, and one of the nice things about Lambda expressions is that you don't actually need the curly braces if you're only performing one action. Okay, if I'm only doing one command here inside of the function, even if it is returning something, I don't actually need the curly braces. So we'll go ahead and remove the curly braces. And then the other thing that we don't need is the actual return statement itself. We can go ahead and remove that. And so that's how we get a shorter syntax here. Looks like I accidentally deleted that last parenthesis. There we go. So that's how we actually have a smaller, easier to read syntax. And this is just a function definition. Take two parameters and perform this calculation using those two parameters and return the result. And that's basically the same thing we did up here, right? Take in a parameter called result and perform this action here. And if you're wondering, well, do I even need the curly braces then, since I'm only doing one action here, one command for that function? Well, you're right, I don't need it. I can go ahead and remove those curly braces as well. So now our code looks a lot smaller, doesn't it? Things are a little bit more terse. They're easier to understand and read. That's one of the huge benefits of using Lambda expressions with delegates and events. Now, you know me, I can't stop just there. I got to take it one more step and just blow your minds. So, what I'm going to show you here is that we've still got a little too much verbosity in our MathService class. Our MathService class has all these delegates, all these events, and things are just a little bit haywire. When it comes to delegates, we actually have some default data types defined in our .NET library. Those data types are action of t and func of t. Now I'm going to start with this delegate of math performed handler. The math performed handler delegate returns void but takes in a double as a parameter. Now whenever a delegate is returning void, that means that it could be replaced with an action of t. So instead of saying public delegate, we're going to say public action. And it's capital A, action. And remember how I said it's action of t. What is the t? What is the data type of t? Well, the data type of t on the action data type is that parameter type, double. So I'm going to go ahead and say action double is the data type. Now, since the action implicitly defines that the return type of action is void, I don't actually need the void keyword here. And since I've defined that the data type for the parameter is double, I don't need to define even this parameter of double. And look at that, we've shortened our syntax even more. But guess what? This is no longer actually a delegate. I can get rid of the handler as well. So now that I've done that, I can go and get rid of my public event. And there we go. So we got rid of our event, we got rid of our delegate. A whole bunch of slimming down of the code has happened here. So since we got rid of our delegate for our math performed, could we get rid of the delegate for calculation handler? Absolutely. Let's just redefine this calculation. But this time, instead of doing action, remember that this delegate is actually needing to return a double. So action was returning void, but since this delegate returns something and it's not void, we're going to need to replace this with func. So we could do something like func. And again, we're going to pass in data types into our func. What are those data types? Well, the first set of data types will always be the data types of the parameters. That's both the same for actions as it is for func. So we're going to do double, comma, double, which represents the two data types of the parameters. And then the last data type that gets passed into func is going to be the data type that should be returned, which it too is also a double. And now that we've done that, we can go ahead and get rid of our inputs and outputs for a calculation handler. But remember how we removed the property of our math performed, right? We needed to remove that math performed property that was of type delegate because now our action replaced it. Well, that's exactly the same thing we need to do, but this time on the parameter. So what we're going to do is we're just going to take this calculation handler, or actually I'm just going to take the func definition here. I'm going to copy that and make that the data type of what's being passed in. And now that I've done that, there's really no definition of a delegate here that's necessary anymore because the func itself defines the delegate, and I can go ahead and remove that definition from my service. Now, what did that do to the program class and how we're using it? Let's take a look. Nothing. It's the same. And in fact, if we do .NET Run, we're going to get the 45,340.516. So this is now using Lambda expressions and using func of t and action of t to describe different functions that can be passed along or assigned to them. This is really cool stuff. It really slims down our code, makes it much easier to read, and also it reverses the dependency. Now, our main method is actually dictating to the calculate numbers what the actual action should be. What is the function I want you to perform? All the MathService does is just say, okay, I'm going to go ahead and run, and takes whatever time it needs in order to do that calculation. I strongly urge you to take more time with your code and see if you can find ways of reversing your dependencies using these Lambda expressions, func of t, and action of t's. I guarantee you it's going to slim down your code, it's going to make it more readable, and things are just going to work in a lot better of a way.